appreciate. Thank you for coming and having me. All right. In case it wasn't obvious from the title, this is about Go development. There's nothing to do with animals. There were no animals hurt in the making of this presentation. I can guarantee that. And yeah, I hope you will enjoy. But if you do not, do not waste your time. I'm not offended if you decide to leave during the presentation. There are so many good talks. I myself had a hard time picking ones for myself. So I wanted to give you a little context about myself and my past. I'm coming here to a security conference as a testing specialist. I'm not necessarily even a security tester, and most of my career have been working for software vendors, software companies. I've worked in software engineering teams, either as a developer, tester, and my perspective at looking at things and why I wanted to talk a little bit about API, Go-related API development is what I learned along the way at my current company, Veracint. And Veracint is in this fraud detection prevention business. I'm more than happy to talk to you about it after the talk. And our primary surface area for customers is API. So I've been in different kind of roles, but again, that's where I'm coming from. So that I'm here. I'm not trying to sell you a business consulting or anything. Also not a security researcher per se. Yeah, just for you to understand. So why I'm here, why I wanted to propose a talk is that, we talk a lot about, even at this conference, about APIs, and for us, it's our primary way to interact with customers. This is our business, and, we are accessing APIs directly, indirectly. And one thing I didn't hear about it at this conference just yet, and then maybe it is obvious to everybody here, is that rarely any SaaS application is a cloud-native application is just providing an API. We are often, these applications are composed of microservices. We are also consuming APIs, so we are on both ends, and this is why working with APIs is to me is important. You may not have heard this expression parafunctional, but parafunctional, sometimes they refer to it non-function, but non-function is a bad term in testing circles because it means something that it doesn't provide any function to the product, but that's not entirely true, since these abilities, security, reliability, and so on, they all come in play when we are talking about APIs. And that these malicious actors cost us business, outages, reduced availability, and the last thing I'll mention, I'll probably bring it up at the end as well, is that I believe we are going to be looking at a very small slice of APIs and possibly how you can make them more robust, resilient. Is that it requires a multi-pronged approach. It's not just at the language layer, but there are many others. So that's just setting again context. And so what I wanted to again talk about is just the Go-based languages, the nuances of Go, and how you can. There are some tricks here about how you can make or create a more defensive application. All of my links and code samples are on this site. I know at a security conference, people don't want to scan QR codes, but there is that link underneath it, so just in case. And this is a kind of I like this image from the pragmatic programmers, where they tell you that, hey, this book, what kind of content do you expect in the beginner to expert scale? So it's more like a beginner to middle scale of what I'm expecting here. Again, a lot of things I'm not going to talk about, those are mentioned here. So I wanted to, at least my understanding, what a typical deployment view of some of these applications that I at least I've seen and experienced, and then go more towards in the weeds of a Go-based application. So in my experience, in a typical cloud deployment, you often have all these players that are interfacing or working with your APIs, and often, as was mentioned in the morning, in the keynote talk, you don't necessarily want to roll your own authentication authorization service. You also often interact with them, and to me, it's really important for the whole team, the engineering team, to understand what kind of protections and mitigation techniques are available at each layer. Best way to do that often is just drawing up a map and visualizing, working together with the team. That I've been doing, I don't know if any of you are familiar with risk storming exercises. Those are also a really good way to figure out where are the certain risks, what kind of mitigations you can employ in your particular context. And I think, especially, that better than I do, often that overlap is okay if you have protection for the same thing and different layers. That is not necessarily a bad thing. Particularly in Go, at least what I've seen, APIs are already deployed as a microservice, like in a container or a Kubernetes cluster as a pod. Or nowadays we have these cloud providers like Amazon providing Lambdas, Google Cloud Functions, Azure Functions. So you can deploy them that way. And there are all these important concerns that you will need to handle with your implementation. So I think I'm gonna mostly talk about this for the rest of the presentation. I'll have some demos along the way too. So hopefully those will a little bit reinforce some of the things that I wanted to talk about. So what I like about Go is that, again, for the most part, to implement an API, you don't actually need a third-party library. Again, in practice, that's not the case, but we had a talk last year, if you were here at LASCON, about how many dependencies, how many third-party libraries an application typically needs, and it was comparing different languages. You all know that JavaScript and Node ecosystem is it's probably the worst offender in this case. But what I love about, my development time when I was a developer full time, spent mostly in Java. But even compared to Java, you rely much less on dependencies with Go, which is great. Again, I feel like your attack surface is smaller. And not to mention, being a tester, I'm just amazed that we have a language that has unit fuzzing, performance testing, this benchmarking, and all built into the library. Not to mention, even at the unit testing level, you have ways to ferret out race conditions. Just as, again, part of the language. Just to me, is mind blowing. So you don't need anything else to install. And of course, there's a bad side, and I have run into some pitfalls too. But all in all, my experience in the last almost 2 years with Go, I've been working with, has been just really lots of pleasant surprises. So speaking of third-party libraries, and this is also a little bit, I think, on many people's minds. There have been a lot of talks today and yesterday too about supply chain attacks and so on. And the reason why I'm bringing this up, because as I mentioned, that for a very basic HTTP server, you don't need any external library, but most of them not, you're going to be depending on third-party libraries, open source dependencies. And one of the things that I we learned, and I'm going to show you an example, is that there's a lot going into evaluating a library, and I often remind some of my teammates when they pick just randomly, I see in a merge request, pull request, a new library popping up, is that why do we need this in the first place? And have you looked at all of these things? The age of the project, adoption, how responsive maintainers are, and so on. How many dependencies it has? Because we often talk about, I have these third-party libraries, but there are transitive dependencies as well, and then you need to be worried potentially about those as well. So on the bottom right corner, you can see here one of my, actually this is the HTTP router library we also use. Look at how many dependencies, 0. So I'm okay, I need to look at the library itself and nothing else. I don't have to worry about its dependencies, which is like beautiful. And of course, it's okay to run your own code scanners on these third-party libraries, and sometimes I run our own linters and so on just to see how mature it is. The other thing I wanted to, again, especially again coming from testing perspective, is that there's this organization, the International Software Testing Qualification Board, that has some certifications for software testers. But one of the really like this section, and I have it in the links as well, is the test manager's syllabus has a section on tool selection. And that tool selection, just the process itself is worth just kind of reviewing, and that just applies to, in my mind, at least it is how it translates to picking third-party dependencies as well, because it has a good checklist, constant things to think about before you bring it in. And GitHub, GitLab obviously have good ideas about and how active it is in the project, these insights and so on. So take a look at it. Like this repository, you can see how many committers there were. It's not just a single guy doing it in his spare time. How many issues have been fixed and so on. So you get a sense, and they have it's worth looking around. So, for example, I also want to give you an idea. You can also test how open those guys are to third-party contributions from outside. I was just looking at this library, considering bringing it in because it has a lot of nuances of this whois.next protocol, the RDAP, and I was like, let me test if they are willing to accept some pull requests, and within 2-3 days it was accepted and merged in. So I was pretty pleased. I'm less concerned about this project being abandoned because I see that I get responses from it. So that's right. Of course, here there is a counterexample that we had spent so much time on. At least I sunk a lot of time on it, and I know of a few others on our team too, is that we use the library for making our REST APIs a little easier. And it was, I don't know who picked it. Again, it's a team thing, so no pointing fingers, but we ended up having it. And then it turns out that, they haven't really released a new version for almost 3 years or 2 years. And that is kind of to me, it would be like a bad signal to look at. And we found a race condition issue that was just, we had no idea it was coming down, where it was coming from, until we found that somebody finally this March merged that in, but they still didn't release a new version. So we were pinning our dependencies to a commit hash, which is like not something you want to do. And this is how it kind of manifested itself in a snapshot from our data log, which is we like it a lot, and we're using a library that takes structured logging on the output, and then that way you can see the different fields. And you can see it was this buffer overrun here that it was obviously messing up this JSON response that we were pulling in from one of our APIs that we were consuming. And that was just, again, not something that I would want to do ever again. So just in general, just a little bit more on the dependency side is that, earlier this year we introduced this tool from Renovate that helps to keep our repositories up to date and keep all these dependencies to the latest version. And it does it, we do it on a weekly cadence, so we see a flurry of merge requests or pull requests that Renovate is creating for us. And it's really a lifesaver, because then we don't have to keep up with that. And as probably with other software vendors too, you will have repositories that are more frequently updated and others that are less so. But you still want to keep the components up to date on those repositories as well. Ideally, you want to have them and find out if some of these changes are breaking your application sooner than later. So, and with Renovate, you can tell them, hey, if it's a minor version change, you can probably just pull it up for update. Otherwise, just create a dashboard for us if there is a major version. On the bottom right corner is one of our public repos. We have a command line interface to our tool. This was just, again, something that came in from our Renovate library. The other very helpful tool, again, part of the language, which is amazing. Go1 check was released, I think, just last year. It was, we have added to our pipeline. So if it is, failing some check, we are going to know immediately about it. And it's an amazing little tool, again, just to ferret out those vulnerable components. And you have probably seen this report in the security around this HTTP2 vulnerability. It's also important to keep in mind that 121.3 of Go just recently addressed this vulnerability, but to make sure that you are actually using that, then there are some directives you can put into your Go mode file that will take care of that. So enough of the dependencies. So for Go API implementations in general, this is how it usually structured. At least what I've seen is that you configure the routes that you want to handle in your API, HTTP-based API, and then obviously you want to configure what methods you want to handle, what others you don't want to handle. Maybe even have a appropriate error message for that, and then disable those methods that you don't want to care about. You route these incoming requests to the appropriate handler function. And there are, again, different ones. There's a built-in one. As I mentioned, we are using this cheap package. Gorilla Mux is also a very popular one that we did use in the past, but Cheese is nicer, cleaner, easier, no dependencies. So beautiful. And when you have the handler function, the router will invoke it for you. One caveat here, as I mentioned that with Go REST as well, is that those parallel executions need to be assumed and expected. So if you have certain data structures, databases, or whatnot that require some sort of locking or making sure that things happen in a serial fashion, then you need to take care of that. And we're going to look at mostly for the handlers in some of the code samples where you can validate, execute, and then send response back to the client. So the first thing I wanted to go over, which is not, I just also recently learned about, is that Go has this nice feature of having a recovery function. And recovery function is when you run into like a null pointer exception or some unrecoverable application error, but you don't want your application to crash. you want to handle it gracefully. And even though the built-in HTTP handler catches what happens in the handler, but if you were to create additional Go routines from your function, then if there is a crash in those, or there's a null pointer exception in those, then that will crash your application. So so this is, for example, like a example recovery handler function, and I'm gonna jump over to the examples just right after that. You can see that with the handler functions, you can pretty much have this chain of handlers that is the parent for Go application, and this would, for example, make sure that you know, if there is a problem in the handler, then it would catch it. You can print out the stack and you know, send back the appropriate error message. You definitely, you know, as a good API developer, you don't necessarily want to explain what happened on the server side to the end user or the attacker. That may be not such a good idea. So I'm gonna jump over to code, and I'm gonna try to make this bigger for you all. So I'm using Visual Studio Code, and one of the nice thing about I like about Visual Studio Code is that it has lots of very nice extensions. One of them is this REST client that understands the .http extensions, and then they can help you execute them in your own editor without having to. I hope it is easy to see from even from the back. So I built this application. Let me just go over it a little bit so that it's easier to see for all of you. So I'm here not using any third-party packages, just at least for the handler functions and the router. So I'm using the Go, and then have some of these handler functions that I'm going to go run through. And as you can see, it just runs a HTTP server at 8080 port, and that's all it does. And I have put some samples here about the recovery functions and how they are doing things, and the different. So, for example, when let me just run this. Oh, of course, I cannot type, and I need to. This will run my basic handler here, and which one is that? So when I run it, it shouldn't, you know, crash it, but it's because it will be caught, and here you can I just sync if I can. Come on, demo gods. Okay. So as you can see, it did a crash for me, but the application is still running. So and if I go to the main, so that was my basic handler. Come on. Oh, yeah, that was it. Why can I go to that? Okay. So that's really the built-in functional thing to Go. So as you can see, the application didn't crash, but and just okay. Maybe I can. It should be showing me on the right. Okay, why doesn't it? Okay. Anyhow, so as you can see, even with the built-in function, the application will not crash. The socket will hang up as it will go for. But if I have like some recovery here that I mentioned before, and I add it here. So this will print out this message if I have this function here. So I can send this request. As you can see, this is what I was looking for. I didn't see it. So now I get back this internal server error, and in the output, I can see that, hey, I detected a panic in the HTTP handler, but I actually gracefully responded back to that. So that's a little bit different. So if I go further, this is going to show you an example here where I'm trying to give you where I have a handler here where I create a go routine, and this go routine invokes a panic helper, which is just pretty much a interface that has a string function that is not implemented, and it will trigger the application to quit because there will be a null pointer exception there. So, and this is only because from the handler function that I have, I created my own go routine. If it were to do this in the main handler thread, then it wouldn't crash the application, but this way it would. So if I do this, you can see the application crashed. Before that, I'll send out this message just in case, but as you can see, the application quit here. So here I have another version of this method or function where I actually have this recovery function already implemented. So even though I run a go routine in the background, I can recover from that gracefully. So I have a request for that. This is different kind of a endpoint here, and if I run this, then as you can see, I still printed out the stack trace and everything, but the application is still up and running. So there is no problem just doing this. All right, so that's on the recoveries in general. Hopefully it was helpful. So in addition to that, I think you can do, of course, a lot of checks with and we heard a lot about some of the HTTP headers that you should be checking and testing. In the morning's keynote, that was like a great reminder about how many HTTP headers we have in general. But at a very basic level, as I mentioned, you want to disable the methods that you're not using. Who needs trace head and options? Options may be needed for your course requests if you're using that. But if you're not, invoking things from the UI, then you may not need that at all. And you may not need all of the get, post, put, delete either. So just why bother? Just make sure that you don't accept them. And some of these header client or request side headers that you can go look at in your codes. Can your client actually accept the content you produce, or what kind of content type do they serve up, and does that match the content you are actually receiving? Is there a content length or not, and is it present? Is it valid? Is it too large? You want to maybe have a limit on the size of the content you want to expect. What kind of content encoding do you really need to be aware of, and content type. We are not even going to talk right now about multi-part data that you can, could be another possible attack vector. But these are just some of those things that we can do. And let me just show you some of the checks that I have in the code for this. I'm going to show you the code first. That will be easier, I think. So as I mentioned, one of the easiest things to do is check for, what kind of methods do you want to accept. And hey, if it's not the right method, I'll tell you that it's not allowed. So what kind of content we can use. And here, just a little reminder here that we actually run into this, that, the content type header doesn't necessarily have to be just the application/JSON. It can have some additional modifiers on top. We had a bug in our code somewhere where we weren't taking care of it. But again, here comes a built-in library into Go that actually can, very nicely parse the media type for you. So it's very easy to make an assertion on that. So why do you want to roll your own and when you don't have to? And then you can make these assertions on whether it's application JSON or not. The other one is that, again, Go has this built-in, which is like amazing, that you can limit the size of the request body. Let's say I want to limit it to 1 kilobyte, and you can wrap your request body reader into this max bytes reader that Go provides, and it will basically bail out if it is too long. So you're not going to even have to deal with that. And I have some examples that we'll run through this. So why don't we actually do that? So this is hopefully. So, for example, this is the case when we send a GET to the post-only endpoint, or if I send this, then I'm good. We are good with this post. If I want to send a non-JSON to something that only accepts JSON, then hey, we can send back the 415. There is a code for that, right? So we can do that. And then when I send this, then with JSON, then suddenly, okay, we are now good with that handler. So, for example, my message, as I mentioned, we have this max body bytes reader. We have this. I have this endpoint that goes to that. Okay, I got your post, and it's of length 16. That's nice. Thank you for. Actually, it's the same as I. But I have this big JSON too. Will you accept that, right? So I can also just, if it lets me. I'll switch back and forth. Sometimes this. Then you can see that this is what I posted to the endpoint, and but this is what I got back. The request was just too large, so it wouldn't accept it for you. All right, so that's it. I think this is. The rest is okay. So that was on that side. So there are a lot of these sanity checks that's easy to do with Go and the help of Go and even just libraries that again built into Go, which is again to me it's great. Rate limiting is another area that we also do in our applications. Many other services that you probably use are also like that, and this is one way to limit how much resources your abusive client or a malicious client or somebody trying to again send you a flood of requests can use up. And these rate limits at a very basic level can be tied to a source IP or port if you don't have any kind of authorization. If there is an authorization, you probably have some sort of idea who the client is and what kind of account they are tied to. So, or you can have a combination of rules and based on just the headers you're seeing. And Go again has a, believe it or not, it has a rate limiting little functions that you can use, but especially in the cloud native deployment where you have probably multiple containers or multiple serverless functions in a fault-tolerant fashion, then you want to have something that shares this state, this rate limiting state with the other workers in your application. So Redis Go is one of those libraries that are actually really nice, and of course it uses Redis cache in the background and can share this rate limiting state across all your workers. And one other thing that I wanted to mention here is that there is obviously some headers that you can send back, indicate to your client that you are over the rate, and then you can retry your request and so on. There is even an HTTP draft around that, which is only a draft, which is interesting. So you will see a combination in implementation to just rate limit dash limit as well as X dash rate limit dash limit and so on. That again inform the client when it is okay to retry. I don't have an example on this, so I'm just gonna go. So fuzzing, again, fuzzing is one of those again amazing things to me is that it's part of the built-in library. The Go tutorial in it, which I actually have on my links at the end, is actually really good. And the fuzzing framework, you write it almost very similar to unit tests. I'm going to show you it in the code very quickly. And a fuzzing is basically having that framework input random data without you having to provide any kind of test data to it to ferret out all those various extreme conditions that you wouldn't normally think about, or it's hard to get that, or hard to imagine some of those scenarios. And nice thing about the fuzzing framework in Go is that it's also it can run forever, of course, without any kind of parameters, but you can time box it. And, especially when you're running it against the local function, it can easily go over, a lot of iterations very quickly. And of course, you can provide it some sort of corpus or test data to do this. And you can, obviously, the best, I think, is just fuzzing the business logic itself. But when it comes to APIs, you could easily fuzz the handler functions or fuzz an API over the network. Maybe you don't want to run it against production. Maybe because of maybe a dev environment would be a better because it could easily generate a lot of traffic if you are not careful, and you don't want to be the one bringing down the production service. So let me just go to this example. So this is my this is in a different repo, but I actually have two different servers up here because I was playing around with some, and I have a simple. I actually borrowed the example from the Go tutorial, and I just wrapped it in a HTTP handler function. And there, example is reversing a string that you are passing in and returning it back. I actually beefed it up a little bit for going over an API, so there is a reverse request, reverse response, so that it can serialize, deserialize from JSON, and this is the handler itself, and there is obviously logic, and I have a original buggy and a fixed implementation for that. And in the good course of things, you usually have a unit test. So this is when you see a t-testing t, then you're talking about the. And let's say I have a single test case here, which is not ideal because you usually want to have not just one, but hey, it passed and it did all the things. It checked whether when you reverse it, then it gets back the same thing. When you want to do it in a handler, of course, you can do the handler itself, as I mentioned, And I commented out some cases that I know will fail with the buggy implementation, but you may not think about them. And this also shows you a little bit of a pattern that is quite common in automated testing, is that you have this notion of table-driven tests where you quickly iterate, you know, define all your test cases at the beginning of a test in a kind of a struct array, and you can just run through them in a big for loop in the middle of the method, and have the testing logic here, so you know it's easy to see what you are testing, and how your testing is separated from that. So I can run over this too. If I were to, you know, uncomment some of these, I know that you know these tests would fail with that, and I wouldn't get the output on it, and it has something to do with the UTF-8 encoding, the bug that it has, so that's one thing. So we can do the fuzzing, and as you can see in Go, when you're doing fuzzing, then you have this testing.f that is passed into your method. The f.add will add some of this, you know, you could load the corpus this way, or you can add some simple test cases. There's a better way to load a larger test corpus to it. But even if you don't put anything to it, you can just, I was pretty much wrapping the same testing into my fuzzing function as I did before, and I can run it from here. Again, all this code is in the repo, so you don't have to. And if I were to run this, I'm pretty sure it would, you know, it runs through here, but of course it just runs one iteration. But from when I'm running from the command line, it will quickly find a test case without me doing a whole lot, that, you know, this test case failed. And what's also nice is that here in the test data folder, it actually saves you this input that it was failing on. So if you were to run it next time, it will try to rerun this. So again, if I go back, and then this was the bug implementation, because it didn't take into account some of those, you know, whether some characters can be runes and not just, and then when you, that's really the problem. If you change this, then suddenly your fuzz testing will also start passing, and you can, you know, run them forever if you wanted to. So this is a way to, you know, test APIs, use fuzzing in your environment. You can, for example, here you can, I'm setting it, hey, run for 10 seconds, so you don't have to, you know, wait forever. If you are happy with, you know, having 1 million iterations on your code, and then you should be okay with that. And, you know, running it for 10 seconds, even in the pipeline, should be okay. In this, actually, one thing I wanted to kind of call out here, and main function here, is that these are some of those things that you also want to go over when you are building some sort of a implementation, some of these timeouts, how many added bytes, and so on. So familiarizing yourself what kind of protections you can give to your application inside Go is also good to know about. All right, so that was a little bit of fuzzing. Hopefully it was helpful. A little bit more I wanted to talk about, and it was mentioned also this morning in the keynote. That's why I'm kind of happy to mention it too. I'm a huge fan of OpenAPI and the JSON schema specification, you know, a JSON payload in this request can have malicious content, but I think the JSON schema is so powerful to help you validate some of the content. And I'm mentioning here a library, Go JSON schema, that to me, the big advantage of it, first of all, it's nicely maintained. The second of it is that we can do less manual coding for validating some of the content that may come in from our API clients. And some of these rules that you can set as part of the JSON schema, which is, I think, really powerful, setting minimum, maximum length for strings in your JSON file. You can leverage built-in types like IPv4 address or a UUID. You can use regular expressions to, property values, but you have enumerations too, and I'm gonna show you that. You can disable additional properties that may or may not what you want when you are updating an API because you want to add more, but you can sneak in more properties in your JSON content you send to an API. And you can make certain things mandatory, which is good. So I have links to all these specs. So this is example from, and what's nice about OpenAPI is that, of course, you can generate these docs. So these are examples from our own website where you can see that, hey, for a particular parameter, we can either require an IPv4 address, on the bottom right corner you can see, or IPv6, and these are just in the JSON schema spec, so just tell them that, hey, this field is IPv6, and that's it. Even though we have it for that, hey, you should only give us like a global unicast address, it will not do that for you. But at least you don't have to wonder whether it was an IPv6 address or not. So that's feel free. This is just examples of that. In the morning, we heard about, hey, what's the best is that you can have like a fixed values that you can accept, right? So enumerations in JSON schema, just like that. So here, if you pass in anything other than these list of values for the type property, then it's going to fail the validation, and you don't have to deal with that. So let me show you the code that I have for this. I'll close this one and have a little JSON validation code. And I want to spend, I still have a little bit of time. And I did a little more, how to say, inquisitive checking here in this function. As you can see, here I can disallow the decoder, again, built into Go, does the JSON, but here you can disable an unknown fields. If it's not allowed, then you don't have to decode them. Again, if there is any kind of unmarshalling error, you want to send back some error. If there is an unknown field because it was not declared in the schema, it will tell you that. Unfortunately, there is no easy way in the built-in Go. You have to check the text, but there is that. Another example I'm going to show you is that you can pass in as a client multiple JSON requests or multiple JSON objects in a single query, but you may not see that unless you try to decode this struct that has two objects in it, and that would flag it to you. So these are some of those basic things that you can see. So let me just show you. This is like a basic example. Like I'm sending to this handler Babs Jansen, and that should be fine, right? It's just, oh, maybe I messed up the page here. Let me just move on because I'm not gonna fix it for you quick. Oh, of course, because I missed that. Anyhow, so demo gods. This is why I didn't find it. So here's a message back that, hey, hello. That was a nice one. This one should have, that's me. so there is a middle initial here, and it says, hey, it's not declared in the schema, so don't send this to me. Here I show you that, hey, I have one extra content here, one extra object in my method. So I showed you that I did some checking there, and then it will tell you unexpected data in request. Of course, you may or may not want to echo it back to the client, but there is a way to detect that from the Go code very easily. All right. This is okay. So the next example I want to show first. I want to show you the code that is like literally easy here. If I find it, let me close this. So here I have a function where I'm doing actually JSON schema validation, and I have a request schema defined. And here I'm using an external library, as I mentioned. And this is the single line of code that actually validates the incoming request against the schema. And the schema can be, if I find it, there it is. So this is a JSON schema. As you can see here, I'm very anal about at least, the first thing must be at least 2 characters long, maximum 20. It must match this regex pattern. I'll give you an example. Similar for last name, middle initial. Hey, I don't want it to be more than 1 character, right? And I want it to be, capital letters, for example. A phone number. It probably shouldn't start with a 0. So, but let's think about, this international format, and let's have it at least 9 characters long. Again, for email, JSON schema has a built-in format. It's email. For RFC 3339 data, it has a built-in format. So it can validate that. So let me just show you. So this is this goes through that validation function that I have in there. And if I send it, it tells you that thank you for the JSON. It's a nice valid copy. But I have an invalid here. And then, for example, lots of rules are broken here. This is not an email. This is not the format that I want for a phone, and so on. So when I send it, I actually print it out on the error that, hey, it doesn't match the format email. It's not a date time format, and blah, 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 blah. And this is actually coming back from that library that I just showed you, that these validation errors. If I can go back. I wish to do this. Show that quick. So here I was iterating over the validation errors for you that came back from the validator library. So again, it doesn't match certain patterns and so on. So it's all in there. So again, JSON schema validation can be super powerful. And there is so much more to cover. And then we are getting very close to the end. So we didn't talk about some of these configuration options, headers, a little bit talk about that. But authentication also is its own method, on topic. It was mentioned in the morning too. I'm glad to hear that I also put it in there. I hate gets, especially when you put sensitive data about it. Not to mention that you don't know what is it along the way, because usually URLs are logged by all those intermediaries, caching of responses and so on. It may require its own kind of workshop if you want to go over all of that. But to recap, I think you need to understand your application, what protections you have available, at what layer. This work with your team. You may have DevOps people, you want to work with, and it's the tool chain itself is important, not just third-party dependencies, but goes as well. You want to make your API resilient, rate limit, create recovery functions, and be very rigorous in inspecting what is being sent to you as a and test your APIs, business logic with fuzzing, emit logs that can trigger threshold-based alerts and so on. So that's again a whole other topic, the monitoring, tracing, alerting as well. So these are some of those things. Again, QR code takes you to this site and has lots of links in here. Definitely OWASP top 10 API security risk. We are at the OWASP conference. I really like a lot of the things that the Open Source Security Foundation puts out. I just recently discovered the Scorecard app, which is also a very good way of testing not just your code, but your containers and then as well. Parsing, good. And again, tool selection from the ISTQB website. And all this is again up on the side. So thank you very much. One ask for you is, again, thank you for listening. I know it's been a very busy 2 days, but if you could rate the session, it would be appreciated, or send feedback. It's good for me, good for the organizers. They may not want to see me again. So, but anyway, it's appreciated. It helps me as well. Thank you so much.